At Station 4, we're going to be testing the different strengths of electromagnets that we can make, both by increasing the number of batteries and changing the number of coils that the electromagnet has. We'll start with the large set of coils and just look at changing the number of batteries first. We're also going to use a tool called a gaussmeter, which measures the strength of electric field and magnetic fields. We're going to specifically look at this second number here, which indicates a magnetic field. And we'll record the strongest magnetic field reading that it can get off of each magnet. We're not going to worry about picking up the staples, so follow along and just write down the gaussmeter reading that I tell you from each electromagnet we make. Be sure when you're connecting batteries to always connect positive to negative. The little dimpled end with the piece sticking out is always the positive end of a battery, and the flat is the negative. If you put them together correctly, they'll amplify each other. 1D battery is 1.5 volts. So each time we add a battery, we're increasing the voltage or increasing the amount of electricity that's flowing through our electromagnet. So let's start with 1. Connect the leads to the electromagnet here. And I will lay this on the desk and then bring the gaussmeter next to it and take a reading. Now, from this magnet, we're only getting 0.32 for a reading. So let's reset the meter and connect 2 batteries to this. Now remember, we always have to connect negative to positive, and the red end of our clips here is the positive, so we want to connect black to red and then red to our electromagnet. That keeps our circuit in the correct orientation. So now we have 2 batteries connected to our electromagnet. Let's see if we can get a reading now. Yes. This time we've got a lot stronger reading at 3.48. It is possible that one of these batteries is a little bit better charged than the one we used first. Now let's see if we can get a third battery on here and get an even higher reading. This becomes a little bit challenging when you're working on your own. Okay, so we've got the positive here, so that needs to be negative. Alright, so now we've got 3 batteries hooked up. Let's see if I can get this to connect. Oops, forgot to reset the meter. There we go, now let's try that again. This battery must be dead. Let's try this again. Trying to find a battery that's not dead. There we go. Now it's working. Alright. Now as you can see, with 3 batteries, we got a measurement of 6.02. It's much, much higher. So based on this experiment, we can ascertain that the stronger the voltage, the stronger the electromagnet. Let's switch back to one battery. And now let's look at the difference between the small set of coils and the large set of coils. Reset our meter here. Now we've got 2.03 with the small set of coils. Take it off, replace it with the large coil, or larger number of coils, I should say. And the highest reading we've gotten off of this one is 3.44. Even this small change in numbers of coils creates a stronger electromagnet. So the more coils you have should give you a stronger electromagnet. This is because of the properties of the spinning electrons as they flow through the coils. The more times you can get them to spin around a nickel, cobalt, or iron rod, the stronger that magnetic field is going to be as they reinforce each other. So it's not the copper itself that becomes magnetic, because copper isn't magnetic. It's the spinning electrons flowing through that copper which creates the magnetic field, which causes the nail to become a temporary magnet because it's moving through an electric or a magnetic field.